All right, so let's talk about isomers. Isomers are two or more compounds that have the same molecular formula but different molecular structures. All right, so let's look at these guys. These guys are all C5H12, and I want you to understand the difference between all of these. Okay, if I write these on the board, they're all, and I didn't write the hydrogens just because I didn't want to take up too much space, but they are there. But like, these guys are actually not isomers of each other, and I want to make sure you understand that. These are just written differently on the board. So this, if you compare this one to this one, this is actually just a flipped image of it. Same exact thing, just a flipped image on the board. This guy is just rotated, and this guy's just written vertically. But these guys are all the same. These are not isomers of each other. Isomers are actually different molecules of the same molecular formula. So let's actually talk about the three main isomers that you're going to probably see. The first one you're going to definitely see are structural isomers. And these are the same chemical formula, but atoms are bonded in different orders. And this one is probably one you're going to see in class most often. So we have C5H12. There are different ways we can write C5H12. We can write it as a straight chain, a straight carbon chain, and that's pentane. We can write it as a carbon chain with a branched methyl group, and that's 2-methyl-butane. I mean, there's several ways we can write it. We can write it as a block kind of structure looking like this with 2,2-dimethylpropane, and there are several more that we can actually draw. There are thousands upon thousands upon thousands of isomers that you can actually draw structurally, that they're actually vastly structurally different. And so they have different chemical properties and different physical properties from each other, but the same molecular formula. Another type of isomer are stereoisomers. Stereoisomers are when all atoms are bonded in the same order, but arranged differently in space. This is actually a little bit more difficult to comprehend and understand. There are two main stereoisomers I want to make sure you know. That's geometric isomers, and that's different arrangement of groups around a double bond. So if you're talking about single bonded carbons, we have this, they can actually rotate around that single bond. That carbon can actually turn itself freely and have not an issue at all. But if it's double bonded, this double bond locks it into place. So you can't actually turn and twist this carbon. So that hydrogen that's up there will always be up there. That hydrogen that's down there will always be down there because it doesn't have the freedom that single bonds do. Same with triple bonds. Triple bonds are the same way. They're locked into place. So what happens if you have two different isomers, one where the two functional groups or whatever's attached to those carbons in double bonding are up? We're going to call that a cis. They're the same. They're both going in the same direction. They're both upwards in the double bond from each carbon. So we're going to call this a cis-2-butene, meaning that the carbons are both upwards. But there is a possibility that one is up and the other is down. That's called a trans-2-butene. So if they're going in the same direction, we're going to call that cis. If they're going in the opposite direction, we're going to call that trans. And that actually makes a vast, huge difference. Notice the melting point of this guy is negative 139 degrees Celsius, where this guy's melting point is negative 106, which is a huge difference. And so not only are their physical properties very different, their chemical properties are very different too. So these guys are what we call geometric isomers of each other. Okay? Last type, and the most difficult probably to understand, are what we call optical isomers. This is a different arrangement of 4 different groups around the central carbon atom. So let's say we have this structure. We have this carbon and it's bonded to these different things around it. And it's the same things around it, however, they're arranged just differently around the carbon atom. These guys are the same thing, however, they can't ever be the same exact molecule. To make it actually a little bit more clear, our hands are optical isomers of each other. They're the same thing. They have all thumbs, pinkies, middle, 4 fingers, but they are mirror images of each other. There's no way that we can actually put one on top of the other and have them be the same. They're mirror images of each other. So these are what we call optical isomers. And optical isomers actually have the same exact chemical properties, the same exact physical properties. It's just they might behave differently and might react differently with different compounds or molecules that are also optical isomers of each other. So they might react differently in a reaction. However, the arrangement around itself is different. So actually, let's talk about 4 different the isomers in this practice problem down here. So we have this compound here, and we want to figure out these guys are all isomers, some type of isomer of this particular compound. So let's look at this guy compared to this guy. Okay, so the main difference between the structure of this and this is this fluorine is down, but this fluorine up here is up. Okay, so this is actually different, and because they can't freely switch around, this guy is what we call a geometric isomer of this. what about this one? This one actually has, let's see, a different arrangement of on this carbon. It's chlorine, hydrogen, fluorine, and this carbon has chlorine, fluorine, hydrogen. This is an optical isomer of this particular one because around here they're completely different. They're arranged differently. Down here, if we look at the difference between this guy and this guy, well, fluorine's down here, where fluorine's up here. It's a completely attached to a completely different carbon. So we're going to call this a structural isomer. So this is an example of the 3 different isomers compared to this particular guy. So these guys are all isomers of this one. So the 3 main isomers, we have optical, geometric, and structural. And basically they're all the same idea. They all have the same molecular structure, but different, formed differently in space. So that's what an isomer is.